Discrete probability distributions is what Chapter 6 focuses on. The study of probability begins with understanding the two basic classifications of a random variable, discrete and continuous. In order to apply the correct formula for solving a probability question, we have to be able to tell whether the variable is discrete or continuous. In this chapter, we're going to investigate commonly occurring discrete probability distributions, namely the uniform, binomial, and Poisson. We explore examples demonstrating situations involving these discrete distributions as well. We're going to define the terms probability distribution and random variable. We'll learn the distinction between discrete and continuous probability distributions. For a discrete probability distribution, we'll learn how to calculate the mean, variance, and standard deviation. We're also going to describe the characteristics of and compute probabilities using the binomial and the Poisson probability distributions. A probability distribution is a listing of all the outcomes of an experiment and the probability associated with each outcome. Probability distributions are characterized by the following. The probability of a particular outcome, usually denoted by P of x, is between 0 and 1 inclusive. That means it needs to be between 0 and 1. The outcomes denoted by x are mutually exclusive, and the list is exhaustive so that the sum of the probabilities of the various outcomes is equal to 1. For example, consider an experiment involving tossing a coin 3 times. We let x represent the number of heads observed in 3 tosses. The exhaustive list for x is 0 heads, 1 heads, 2 heads, and 3 heads. Altogether, there are 8 possible unique combinations of how the 3 coins will appear, as shown in the table in the slide. The probability of observing 0 heads is one of 8 outcomes. Since the list of x is exhaustive, the sum of their probabilities is 1. Discrete probability distributions have the following characteristics. 1. The probability of a particular outcome is between 0 and 1 inclusive. 2. The outcomes are mutually exclusive events. And 3. The list is exhaustive, so the sum of the probabilities of the various events is equal to 1. In an earlier slide, we considered an experiment involving tossing a coin 3 times. We were interested in observing the number of heads in 3 tosses. We denoted this random number as x. The table on the slide now shows the exhaustive list for x. 0 heads, 1 heads, 2 heads, and 3 heads. Altogether, there are 8 possible unique combinations of how the 3 coins will appear, shown in the table in this slide. The probability of observing 0 heads is one of 8 outcomes, or 0.125. Because x is listed exhaustively, the sum of their probabilities is equal to 1. The figure on the right of the table graphs the probabilities of the respective outcomes. The resulting graph outlines the shape of the probability distribution of this coin tossing experiment. Now I want to cover random variables. A random variable is a value or number that results from an experiment that by chance can take on different values. We usually use the letter x to denote a random variable. So in the coin tossing experiment we discussed in the previous slides, the random variable of the experiment is the number of heads that will appear in the 3 tosses of a coin. The possible values are 0, 1, 2, or 3.